Hey, this is Don from Padlock Technologies again. As promised, this is the MP-BGP EVPN multi-site lab. So we went over the theory in the last video. Now I did this lab, and like I said before, the data plane does not work because it doesn't have the ASIC to do this, but we can at least verify some things. So I want to show you how big this lab is actually, so you guys see what I'm saying. So this is the lab. So let's take a quick look. We have data center 1, we have data center 2, we have a data center down here, number 3, that I did not configure because I didn't feel like going through that. And then we have the DCI here, the data center interconnect. This is very important when it comes to EVPN multi-site. And then we have a mock fake, HQ, something like that. Let's say these are DCIs in between. I'm running BGP here as well. Now I'll be able to ping these devices from this machine up here, which is VPC, but these devices will not be able to ping each other over the the EVPN multi-site connection, or the DCI, because again, the ASIC does not work. So with that being said, let's jump right into this. So let's go to data center 1. So data center 1, very simple design. I'm using /31s. If you're doing point-to-point links, /31s are kind of the way to go. Depending on who you ask, some people like /30, some people like that /31s. /31s allow you to use all the space in a subnet, so you can actually use a .0, wherein /30s you can't. So you can conserve some space with /31s. But here's my spine here. So if you're thinking about the spine here, and let's see, let's log into the spine and let us look at these configurations here. So I'm just going to show the neighborships here. So on the spine, I'm just doing L2 VPN. So I'm not doing IP4 unicast. So if we just do this, EVPN, and then summary, you're going to see the EVPN, right? So this is what you would see, and these are on Nexus switches, right? You can technically do EVPN on routers as well, but you don't get this. It looks a lot prettier on Nexus switches. So as you can see from routers, or from Nexus switches, 3 or 4, 5, 6, and 7, I gave them these IP address. So to correlate, Nexus switch 4 is .3, 5 is .4, 6 is .5, 7 is .6. Now I could have made them the same, but I just, numerical value here. Now you see there's type 2 routes. Now these are the MAC and IP routes that are in EVPN. Now there's type 2s, type 3s, type 4s, and type 5s, right? And type 1s, but type 1s are auto discovery, right? Type 5s are going to be routes that are external to the fabric. Type 2s are going to be within the fabric, within the same tenant and stuff like that. So as you can see, I'm receiving these routes. You see all the states are up. I'm using BGP, 65001 on this one. So if we were to look into the actual L2 VPN EVPN table, as you can see, here we go. So this .2 is actually coming from the other data center, because this endpoint 1 and endpoint 1 VLAN 11 down here, this is 10.100.1.1 and this is 10.100.2.1. The 10.100.1.2 is actually on the other side of the fabric, so it's in data center 2. But I see it in data center 1. This is the stretching of the VLANs, right? This is stretching layer 2 domain over physical two geographically physical locations. This technically, in real life, this could have been in Maryland and the other one could have been in LA, right? But once you do this configuration over to DCI, they pretty much look like they're right next to each other. So now that we're looking at this, you see the .2 here as well, the 10.100.2.2, which is on the other side of the other data center. And you notice that you see these here, right? You're going to see these are my site IDs. So my site when you do multi-site, you got to give a data center a site ID. So the site ID is technically a loop back that's on the border gateway. Now, if you look at 6 and 7, those are technically my border gateways because they connect down through the DCI, right? And 101, 101, 101, 101 is technically, I hope I didn't say too many 101s there. This is technically site 2. So as you can see, these are type 2 routes right here. This would tells you what type 2 routes. So this is MAC and IP. And as you can tell, 48 bits, 48 for the MAC, right? And then 32 for the IP address, right? So here's the complete, right? That's the complete binding here. So as you can see, it's a 42 bits there, the hexadecimal, and then 32 for the address. Now that's all site 2 stuff. Now, let's see what we got here. Now here is local to site 1. I just saw it. Let's see here. Let's see what. Here's local, right? MAC address 101, right? So if we look here, we go show IP. You see the MAC address here ends in 6801C, 681C, and then 10.100.1.1, 10.100.1.1, right? So that's from the spine's perspective. So from the leaf perspective, though, and this is why this technology is actually great. If you know ACI, this is what ACI is actually technically doing under the hood. So if we look at this VTEP, which is leaf 1, first thing we're going to do is we're going to do show NVE peers. So these are my NVE peers. So this one is the router 5, I keep saying router, Nexus 5, Nexus 6, 7. This address is when you do this, you're going to give it a secondary address for load balancing purposes. And the only reason I'm doing this is because I'm doing VPC. If I wasn't doing VPC in any of these, I wouldn't need this secondary address. But because I'm doing VCP, you need that secondary address because that is the address that's going to advertise the routes, right? When they're both connected to the same downstream. And then this is technically for multi-site. So if I wanted to send something to the other data center, I'm sending it to this IP address. I'm going to get a tunnel to there, and then I'm going to do ingress replication to the other side. So that's the NVE peers, right? So now if I do, and I'm going to show you, let's go over to 10, right? This is the second show IP. So as you can see, this is 10.100.1.2. Now, if I look at the MAC address in site 1, if I do show MAC address VLAN 10, as you can see, you see that 0000. Now this 6822 should match the MAC address from the other site. That, again, is a verification of the layer 2 domain stretched amongst 2 physically independent data centers. So if the ASIC was technically working in this lab, I would be able to ping 10.100.1.2 from 1.1, and they basically look like they're sitting right next to each other. And we can verify that in data center 2. I might have messed that up right there. But we can verify that in data center 2. I keep fat fingering this thing. Once I can log in. Let's do it slow. Make sure this works this time. There we go. If I do show MAC address, address family VLAN 10, same thing, or MAC address table VLAN 10, here's the MAC address from endpoint 1. So if I go to endpoint 1 over here, and I just do show IP, same thing here. So 681C. and that is being seen at the other site as well, saying, hey, if you want to go there, you need to go to the multi-site address in your location, and then we'll do ingress replication that way. So that's multi-site in a nutshell. And same thing with, 11. So if I wanted to do, let's say on 4, if I just show the MAC address of VLAN 11, same thing. That's the other MAC address 6820 is on the other side. So if I went to 11, show IP, and there you go, 6820. And then if I go on this side, I do show IP. And then we look at this here. As you can see, 6821 is on this side here. So that validates, hopefully you guys don't hear my dogs in the background. They're screaming for some odd reason, so I apologize for that. But as you can see, 6821 is on that side, which matches with this here, 6821. So that validates that layer 2 domain is stretching. EVPN is amongst both, is being stretched for layer 2 for VLAN 10 and 11, and DCI connections are working. So how does this actually work from the border gateway perspective? So from the border gateway perspective, you got to do this thing called EVPN multi-site border gateway, and then you have to actually give the NVE interface a multi-site loopback, and then you have to actually configure BGP to your DCI and then configure EVPN to the other side. That's how you do it in a nutshell, right? So if we take a look at, let's see here. We take a look at one of the border nodes or border gateways. So first things first, let's show the NVE peers. That's all the NVE peers. So as you can see, I have a peering with the other side, and I have a peering with the other gateways, and then I have a pairing with my own data center stuff, right? So from there, if we take a look at the NVE interface, you're going to see what I'm talking about with the border gateway. So this command is actually saying, hey, your loopback 1 is going to be the identifier for site 1, which was the 100, 100, 100, 100, right? Now, here is the ingress replication, because over the DCI, you don't do multicast over the DCI. It has to be multi-site ingress replication. That means these Nexus switches are going to make a copy of the packet and send it to both border gateways, right? Because you have that designated forwarder issue where if you only send it to one and that's not the DF, then it just drops the packet. So you just have to send it to everybody in the multi-site configuration. What else is there that we want to talk about? Let's see, from a BGP perspective, this BGP configuration is going to be pretty long. So from a BGP perspective, if we're looking up here, we have our, address family unicast. Now this EVPN multi-site is going to redistribute a routes with a certain tag value, and that's going to be my loopback addresses so that I can do the EVPN peering between it. This advertised PIP for L2 VPN, you do this when you're doing VPC, because if you happen to not have something connected to both, well, it needs to advertise the individual loopback and not the VPC loopback, right? Which is your secondary. Not to advertise that as the way to get to the route, because if you do that, you might end up sending traffic to a VPC peer that doesn't actually have connected to the single node, and that's like an orphan port. Then I'm using this peer template, peer session template for EVPN. The key here is you're going to do it off the loopback. You're going to make sure you do EGB multi-hop, because if you don't, the pairing won't come up. And I did 255. Obviously, you can control that, but I just did 255. And then this is important as well. The peer type fabric external. This is telling it, hey, you're going to do EVPN, but it's going to be external to your fabric. So when you stretch this, just know this is an external fabric member here, or a fabric pairing. The rest of this here is pretty much IPv4, right? And you're going to use this IPv4 stuff to actually do EVPN over the top. So you only need IPv4 to advertise the loopbacks, and then when you got the loopbacks from the other border gateways, now you can just do EVPN or L2 EVPN address family for the loopbacks of the border gateways. If you try to do VPN before, if you try to do L2 VPN, EVPN, and IPv4 unicast, you will start getting a loop where it starts to bring down the neighborship because it's saying, "Hey, I see it in two different ways, and I don't like that." So it will bark at you. This tenant configuration, this is technically on Nexus 4 and 5, but this is how we would redistribute those routes from the fabric or from downstream. These switches here are this element here. This, where VLAN 10 and 11, these switches are, and this is technically doing a port channel here. But what I'm saying is I'm going to redistribute the routes that I own, right, that I know about, the /32s. And this all route is just a blank route map. When you do a route map on a Nexus switch and nothing's in it, it's just, and you redistribute it, you're just saying redistribute everything. And then this is actually going to the headquarters, and what you're going to see is these /32 routes are going to be in the headquarters switch, and then I can ping it from there, right? I can ping within there, but again, data plane for multi-site just doesn't work because of the APIC. The EVPN configurations are your layer 2 VNIs. So this is stretching the VNIs within the data center. So let's say technically if I had another downstream box here in this area, if I had another downstream box in this area here, and it was the same, VLAN 10, then I'm stretching that layer 2 amongst all of these, right? Now the thing here that we gotta make sure we get is this is all layer 3 in this data center. All of this, right? But it's still classical Ethernet downstream, and then when it comes up to here, gets encapsulated in VXLAN, and then VXLAN basically takes it to the VTEP that has the layer 2 routes, or route type 2s, basically, the MAC and IP. So it will tunnel that traffic to the next one, right? And then this VRF is technically tenant 1. The good thing about EVPN multi-site is it is multi-tenancy, so I can have a different VRF called tenant 2, and then I would put the new subnet. So if I do interface, let's just do interface VLAN 10. So if I show you interface VLAN 10, it's under tenant 1. If I had VLAN 12, it could be tenant 2, and those two routing tables are technically separate amongst each other. If you know MPLS, this is nothing. This is basically almost like MPLS, how MPLS works. You just have a separate VRF table. Those two tables never see each other. They don't know anything from a routing perspective. And then you just dump all the routes into the L2 VPN EVPN table, whereas in MPLS, L2 or L3 VPNs, you're going to send it into either the VPN v4 table or the VPN v6 table, depending on what you're doing. Now, this tag, I could have redistributed this, redistributed this subnet based on the tag value, but I didn't do that. HMM is the better way to go. And then you might see this command here, which is fabric forwarding anycast. So the other thing about this whole setup in this technology, same thing with ACI, same thing with SDA. They have this concept called Anycast Gateway. What does that mean? So Anycast Gateway helps you with VM mobility or workload mobility, because it doesn't always have to be VMs. So this subnet or this gateway, which is 10.100.1.254, exists. Let's open this up here. This exists on all the VTEPs. All right, this exists on every last one of the VTEPs here. Excuse me. Let's log in. See that? Same address. So what does that do? Well, let's say you had a big data center and you had 3 spines and then you have a bunch of VTEPs underneath it. Well, technically, if I were to try to do this at L2, obviously I would need a top of rack switch, plug it in. There'd probably be something in the middle there from a collapsed core perspective, or a distribution switch that goes into a core 3-tier design. But you still have the L2 problem. What this does, and especially with the multi-site component, is if this was in real life, not a virtual, I could take this workload and move it to anywhere in the data center, and I don't have to worry about re-IPing, and I don't have to worry about layer 2 in my data center. In fact, I can take that same physical or virtual server, move it to data center 2, and I won't have to worry about ARP issues. I don't have to worry about re-IPing. Why is that? Because if I show you the fabric forwarding MAC address, this here is the fabric forwarding Anycast gateway MAC. That is configured in data center 1 and data center 2. So now you don't have to worry about an ARP issue because that MAC address is hard coded, right? So every time they go to ping their default gateway, it's always going to resolve to whatever MAC address I gave it, even in data center 2. So this is where this technology is better than doing layer 2 in your network, because A, you don't have to worry about the routing loop problem, or not routing loop, but the L2 loop issue with spanning tree. You got ECMP going on, you have multicast, no broadcast going in your network. Everything is multicast at that point. You have this Anycast gateway going on. That means I can move workloads wherever I want to go. Like if I were to go down, I can move these workloads if I wanted to in real life from this data center 1 to data center 2. And if I actually configured this and I didn't, I can go to data center 3 and do the same exact thing. And it's all going to look like, whether they're in data, I can have a workload in data center 1, data center 2, and data center 3 have the same L2 domain stretch, and they will all look like they're sitting right next to each other. That is the benefit of this technology, or this technique, this EVPN technique. You can't really do this with anything. And this, again, is what ACI, is what Nexus dashboard, DCNM, SDA, all this does this under the hood. So if you know how it works under the hood, it's pretty easy to kind of figure out what's going on with, those automated technologies. So now let's look at this switch up here. This is a mock switch here for a headquarters, DCI between it, and this is how they talk to their data centers. I could have put SD-WAN in here. I could have did DMVPN. I could have did Flex VPN. I could have did a lot of stuff, but I just decided to directly connect it to it, so to make this lab a little bit easier to understand. So now if we're looking at it here, if we do show BGP, I'll just do VPN v4 unicast. Here's all the routes. As you can see in the routing table, you see these /32s. Here's 2.1, which is in data center 1. This is 2.2, which is data center 2. This is 1.2, and it picked this route as the best route there. And then there is 1.1, which picked that one there, which is fine, right? From a routing table perspective, though, let me show IP routes, BGP, there you go. So to get to 1.1 is going to go to this link here, this .1. To get to 1.2 is going to take 4.1. To get to 2.1 is going to take 1.1. And to get to 2.2 is going to get to 4.1, which is a little, let me see something real quick. Okay, so it is up. All right, so that is up. So let's go to VPC, show IP, all right? And I'm also advertising this subnet. This is a subnet that's local You can tell because it has that 32768. That means it's a local route. And I'm advertising that into BGP so that the data center 1 and 2 know how to get there. And you can see that right there. All right. So now that correlates with that. Here's my gateway, which is on the main switch there, or the correlate switch. Now, if I were to ping 10.1.100, I almost made that mistake, 1.1. Works perfectly fine. That's going in the fabric and coming out. That's going into the fabric and coming back out. That's data center 1. And if I wanted to go to data center 2, that's going into data center 2, coming back out. And if I wanted to go to 2.2, that's data center 2 and coming back out. Now, I would Wireshark this, but because there's ECMP there, you may not see the VXLAN packets coming in because you don't. Let me try it. Let's see if we can Wireshark this. Because if we can see the packet, then it's easy for me to show you the VXLAN encapsulation. There we go. We can see it. All right, so let's pause it. So I'll go here. Because if you go here, you'll see some stuff as well. I could swear I paused it. All right, so from me, or from VPC1 and correlate, going to 10.100.1.1, as you can see, span this out real quick. We have the Ethernet frame. We have the destination here. So this is coming from the VPC addresses. So 10.255.255.251 going to 10.255.255.250. All right, so that's my VPC addresses. Now, here's the UDP packet because VXLAN gets encapsulated. Well, VXLAN encapsulation, and then it gets put into a UDP frame. 4789 is the UDP port that it uses. Source port is just randomized source port. Here is the VNI information or VXLAN information. So if we look at that, look down here. So let's look at a little bit more information here. So we have the VNI ID is true. Then it is using VNI 3000 because this is my layer 3 VNI. So when I want to actually do some routing here, I use this VNI. If I was doing, layer 2, so if I had another workload in the environment in data center 1 and I pinged it, it would use the VNI 10 because I made VLAN 10 VNI 10. So how that works is VNI is significant to VXLAN, and then the VLAN is significant to classical Ethernet, so downstream. VLAN only matters downstream, VNI matters within the fabric. And then after that gets wrapped, you can see it wraps the frame. So if you look at this all together, you have Ethernet, then you have IP, then you have this UDP packet, then you have VXLAN that wraps another frame, and these are the MAC addresses and stuff like that. Then it has the IP packet, and then it has ICMP in there. So that's a lot of stuff. And this is why your MTU needs to be jumbo frame or 9216, because if you don't have that on there, a lot of this stuff is going to break. So that's from correlate to DC1. Now, if we look at the reverse, all right, look at the reverse. We have the frame, Ethernet, IP, which is going to destination 5. So it's coming from the VCP going to destination 5. So that is Border Gateway Nexus OX6, because I believe that's the forwarder. Here's the the UDP wrapping. Then you see the VXLAN. As you can see, VNI 3000, because it's the routed layer 3 VNI, not the layer 2 VNI, which is within the same layer 2 domain, like I said. Then we have the Ethernet frame again. Then we have IP, and then we have ICMP. Ultimately is what wraps into it. So that is MP-BGP EVPN multi-site in a nutshell. Again, let me go extend this just a tad bit so you can see it. This is what ultimately it would look like in a real design, like when you're designing this for somebody for network architecture kind of thing. This is what I usually do just to show them the concept, like they can grasp it. But this is what it would look like. This VNI, these VNIs would basically be, I would make them the same. I wouldn't really change the VNI. So if you make VLAN 10, VNI 10, data center 1, make it in data center 2 and 3. Don't try to get cute and make it a different VNI because you can run into some problems. This DCI doesn't technically need to be 4 routers. You don't need to, right? You don't need to do that. You can have 1 router on each side and then have those connect in between and do that. I just did 4 because I was bored. And plus, from a redundancy standpoint, I got 4 different ways to get somewhere, right? Or 4 nodes that I'm connected to and have 2 different connections for each router. So I have just redundancy on top of redundancy, right? And then same thing would have worked out for data center 3. Once I would have set that up, then I would technically see the MAC addresses from data center 3 and data center 2 and data center 1 and data center 2. But yeah, that is MP-BGP EVPN multi-site in a nutshell. Hope you guys enjoyed this video. It took me a very long time to do this because I had to do it from scratch and from memory. I haven't really done this technology in probably a year or so, manually at least in a year or so. So now it's all ACI and stuff, mainly ACI. I don't really do Nexus dashboard. Hope this was informative. Got questions on a little bit more technical questions about this, or if you got questions on other stuff, send them to me. Don't forget to share, comment, like, and subscribe. Hope you enjoyed this as much as I like teaching you. Thank you. Have a nice day.